Hi, this is Prasanna from Wave Academia. In this part of video, we are going to discuss about EV powertrain sizing using MATLAB part 2. So in the last video, that is a part 1 video, we discussed about machine sizing using MATLAB. So for the given specification, how to develop the machine. So what is the requirement of machine? For an example, what is the power required to drive the machine, torque required to drive the machine, and speed of the machine in RPM. Those things are all we discussed. We did it with the help of MATLAB also. So in this part, we are going to do the battery pack calculation for the given vehicle. In this case, we took a four-wheeler and the specifications are given here. Whatever the battery requirement to drive that given four-wheeler is, the operating volt required is 48 volts. The capacity of battery, that is the current requirement, we normally say the current requirement capacity, that will be 280 ampere hour. The standard consumption of the machine is 88 watt hour per kilometer. So if it is a conventional vehicle, we normally say that the standard consumption is, I can say for an example, 88 kilometer. No, we never reach 88 kilometer. I can say that 25 kilometer per hour. Sorry. We normally say 25 kilometer per liter of fuel. Say it may be a diesel engine or petrol engine, for an example I'm telling. So that is nothing but it is a standard consumption. In case of electric vehicle, that's a battery powered electric vehicle, we normally say that the standard consumption is 88 watt hour per kilometer. So if you look at this case, the cell specification is given here. It's an individual cell. We know that the number of cells connected in series and parallel, we normally call it as a battery pack. Okay. So in this case, whatever the cell we are using, it's a prismatic cell, that is lithium ferrophosphate cell, and the nominal voltage of single cell is 3.2 volts. The current rating of single cell is 65 ampere hour. And the mass of single cell is given here. It comes around 1.8 kg, and DOD, that is nothing but it is a depth of discharge, is 95%. What is depth of discharge? Let me consider this is a battery. I can say that this is 0%. That means it's a complete entry, and I can say that this is 100%. That means a complete full. But you cannot use 100% of battery. You can use only 90 or 95% of battery alone, because this will increase the number of cycles of battery. So this depth of discharge will be normally given by the battery manufacturers. Okay. So according to that, you can use the battery. So no one can use 100% of battery. So you can either charge the battery or discharge the battery only up to 95% or 90% according to the requirement. That is called depth of discharge. And the dimensions of single cell is given here. The length, breadth and thickness is given here. So what we are going to calculate is how many cells required to build a battery pack. Okay, that is a total number of cells. How many cells you have to connect in series, how many cells to be connected in parallel, what is the peak capacity of battery pack weight, and range calculation. So within this, the given specification, you can easily calculate the range covered by the distance covered by the vehicle also you can calculate. So for those things, you need a formulas. If you want to calculate the number of cells connected in series, pack voltage by nominal voltage. In this case, packed voltage is 48 volts, nominal voltage is 3.2 volts. So 48 divided by 3.2 will give you number of cells connected in series. Similarly, you can calculate the number of cells connected in parallel, that is pack rating divided by that is single cell ampere hour rating. So what is the pack rating here? 280 ampere hour divided by 65 ampere hour, which will give you number of cells connected in parallel. Once you multiply both, it will give you the total number of cells. You can easily calculate the battery pack because the length, breadth and thickness is given, which will give you the total volume of battery pack. Okay, as in this case, if you look at this, the cells dimensions are given in only millimeter. Okay, we normally represent the battery pack capacity, volume of battery in liters. You have to convert millimeter into liter. That we'll do in the simulation. Second, you have to calculate the usable capacity of battery. This is very important here in this case. If we want to calculate the total capacity will be given by voltage rating of complete pack multiplied with capacity of battery. So this will give you the total capacity of battery. But we know that you can either charge the battery or discharge the battery up to the depth of discharge. In this case, the depth of discharge value is given as 95%. So what is the usable capacity of battery? Usable capacity of battery is given by voltage into capacity into the depth of discharge. This is the formula if you want to calculate the capacity of battery from source to battery. Okay, so in my first simulation, I am going to calculate the usable capacity of battery from source to battery only. But normally, whenever you are going to the shop or whenever you are going to design a vehicle, okay, you need some requirements. See, for an example, if we take a two-wheeler, I want a two-wheeler that should reach a minimum of 80 kilometer. So if you consider it's a two-wheeler electric two-wheeler, it is more good if you travel in a city which covers 80 kilometer per day. So this is your requirement. What is the requirement? My two-wheeler should cover maximum range of 80 kilometer. To satisfy this 80 kilometer, I am going to calculate the capacity of battery. So in such a case, that is a load to battery, this is the formula. Voltage into ampere hour divided by depth of discharge. We should be very careful about the formulas. And you can easily calculate the weight of the battery pack, that is weight of single cell into total number of cells. At last, you can calculate the driving range. What is the range given by the battery? That will be done by usable battery capacity by using this formula. Usable battery capacity by standard consumption. That standard consumption is given in the requirement itself. 88 watt hour per kilometer. Okay, so with this specification, I am going to calculate my battery pack. I am straight away moving on to the MATLAB. Okay. Accordingly, I will take the inputs. I need totally 12 inputs. Okay, I am taking 12 inputs. I'll go very slowly, okay? So you can easily follow me. So whatever I'm doing now, I'm just giving the inputs. This point is nothing but it is a depth of discharge. We normally say that depth of discharge in percentage. Values and all I'll do it later. And then you can take this one is itself weight per cell in kg. These are all given in the specification. Let me take these are all cell dimension. Cell length in millimeter, cell breadth in millimeter, and cell thickness in millimeter. Standard consumption, little bit it's watt hour per kilometer. So as of now, the inputs are given. Let me put the values also. So as per the equation, if you want to find out the number of cells in series and number of cells in parallel, you have to use this formula. So let me do that one. Pack voltage divided by nominal voltage and pack rating divided by cell rating, which will give you number of cells in series and parallel respectively. So I need a divide. I'll tell you what is maximum cell voltage and minimum cell voltage, what you can measure with the blocks. I'll tell you. Pack voltage divided by cell voltage, which will give you number of cells in series. Similarly, pack capacity divided by cell capacity, which will give you number of cells in parallel. Right, and then total number of cells. Simply multiply these things, and then if you want to calculate the volume of battery, simply multiply length into breadth into thickness into total number of cells. total number of cells in series and total number of cells in parallel, which will give you total number of cells. And then if you want to calculate the total capacity, that is total energy, so how to calculate total energy? Simple. If you multiply pack voltage and pack capacity, which will give you total energy. Pack voltage multiplied with the pack capacity, which will give you total energy. But actually we don't want total energy, we want available energy. How to calculate available energy? Simply multiply this total energy with the depth of discharge. Okay, which will give you available energy. See, there is a lot of difference between total energy and available energy. You can use only the energy available up to the depth of discharge. Okay, so now you can calculate total weight of battery pack. So what is total weight of battery pack? Simply calculate. Simply multiply this one, that is total number of cells into weight per single cell. This will give you total weight of battery pack in kilogram. If you want to find out the volume of battery pack, you need cell length, cell breadth and cell thickness. That is, these are all individual cells dimension. Okay, so if you simply multiply this one, I need a product. You can change the number of inputs in product. It beats 3. Which will give you volume of single cell. The unit is millimeter cube, cubic millimeter, right? But we never measure, we never say that the volume of cell in cubic millimeter. I need it in liters. Let me take a product. So we have to multiply this volume of single pack with total number of cell, which will give you volume of battery pack. But we never say that volume of battery pack in cubic millimeter, that should be in liters. Okay, there is a formula to convert cubic millimeter into liter. So let me take again, you can Google it. Let me take again. If you put a gain value of 1 divided by 10 cap 6, which will convert the cubic millimeter into liter. This is volume of battery pack in liter. At last, you can go for range calculation. So we know that the formula to find out the range is usable battery capacity divided by standard consumption. So what is here? Usable battery capacity. Here it is. That usable battery capacity is nothing but it's available energy. Available energy divided by standard consumption will give you the range. Available energy by standard consumption will give you range of vehicle. So here, if you look at this, I left two more value, that is maximum cell voltage and minimum cell voltage. So whatever the cell voltage given in the specification is coming around 3.2 volts. But actually, this cell, it won't give you always a 3.2 volts. When the cell is fully charged, the output of cells may go up to 2.4 volts. That will be a maximum value. When the cell is about to discharge, the output voltage may reach 2.7 volts. That will be a minimum value. So, okay. So with this maximum and minimum value, so what you can identify is what will be the maximum operating voltage and the minimum operating voltage. As of now, whatever the operating voltage given is, it's nominal operating voltage. Okay. So with this one, you can easily find out what is the maximum operating voltage value and what is the minimum operating voltage value. Because if the voltage reaches lesser than this minimum voltage, actually it won't drive the machine. It won't drive the vehicle actually. So you should be very careful about that. What is the maximum voltage you can go? What will be the minimum voltage you can maintain? So based on that, your control system will work. So for that, I'm going to use a maximum cell voltage. So let me take this case. I want voltage, right? So voltage is always a relationship with me take a product. Let me take a display. Maximum operating voltage, that is maximum pack voltage, and minimum pack voltage. Maximum cell voltage divided by this number of cells in series, which will give you maximum pack voltage. Similarly, minimum cell voltage multiplied with number of cells in series, because we need a voltage. Actually, I need a maximum voltage. So voltage will always having a relationship with number of cells connected in series. So now these are the battery pack calculation using MATLAB. It's actually, the program is quite easy. So whatever the blocks I used, it's a simple addition, multiplication, division and gain blocks only. Okay, program is very simple. You can easily use the formulas to find out the battery pack calculation. Here, one thing I'm going to change. One change I'm going to include that. See, whatever the values you are giving according to the inputs, it will do the calculation. So if you take this case for an example, if you divide the cell voltage by, pack voltage divided by cell voltage, which will give you some floating point values. Say I can say that 13.6, 13.5, something like that, or 13.2. So will you purchase a battery pack? For an example, will you purchase a cell like give me 13.2 cell, 13.5 cell? No one will give you. Okay, according to the production, if the entire pack production, cell voltage, cell production is completed 100%, then I can say that it's a one volume. Okay, so up to that, I'm going to use only the floor values. So in case, see, even though if it is a 13.9 or 13.1, in both cases, I'm going to use only the floor values. The reason is, according to the production, once the product is completely produced, 100% it is produced, then I can number it. Otherwise, I cannot number. Okay, so in this case, I'm going to calculate, I'm going to take only the total number of cells which is completed. So what I'm doing is here, let me take a floor. I'm going to place a floor here. Now I'm going to put up the values. So let me take that maximum cell voltage, let it be, it's 4.2. Minimum cell voltage, I'm going with 2.8. Accordingly, you can design. So according to the specification of cell, you can design it. So in our case, the pack voltage is 48 volts. Cell voltage is 3.2 volts. You can refer it. And then pack capacity is 280 ampere hour. The individual cell capacity is 65 ampere hour. And in our case, the depth of discharge is 95%. So 95 divided by 100, which will give you depth of discharge in input 0.95, and weight per cell is, it's coming around 1.8 kilogram. Individual cells weight is 1.8 kilogram. And similarly, length, breadth and thickness in millimeter. Length of the cell is 228 millimeter. Breadth is 268 millimeter. And thickness of cell is 17 millimeter. And what is the standard consumption? It is 88 watt hour per kilometer. So now if you run this program, you can change the step time as 2. This is enough. Yes, now once you run this battery pack program, it will give you whatever the requirement actually wants. I'm running it. You can came to know that, see, what is the maximum pack voltage is 63 and minimum pack voltage is 42. But whatever the case, what we need is 48 volts. If the maximum pack voltage is going beyond 63, you cannot use it. And similarly, if the minimum pack voltage is going less than 42, you cannot drive the machine. So what is the total number of cells connected in series is coming around, it's a 15 cells. And whatever the total number of cells connected in parallel is 4.308. See, as in the case, that's what I mentioned here. 4.308, I cannot take this value and make calculation, because whatever the total number of cells completed is 4. That's why I took here, in this case, I took the floor value of total number of cells connected in total number of cells. That's why I took floor value. Okay, so whatever the energy, total energy required is, if you want, just double click it. Double click it, go to long, similarly here. Okay, so if you look at this, whatever the total energy is 13,440 watt hour. But what is the available energy? What is the usable energy you are having? Only 12,768 watt hour. Okay, and the total weight of battery pack for this four-wheeler, it's coming around 115 kilogram. Similarly, you can do this one. I want it in long. Double click it to long. Apply it. Okay, so if you look at this, whatever the volume of battery pack in liter it is giving, it's coming around 66.48 liters. So what you can say is, accordingly you can design your vehicle. So based on this battery pack required, you can make a space on your vehicle. Okay, and what, see, the last one is very important, the range. Whatever the range it's given is 145 kilometer. Actually, whatever the value I'm using, it belongs to Mahindra electric vehicle, but it's not an Indian version of vehicle, it's a European model. You can check it out. So this is the case, you can use the battery pack calculation. Suppose if you want to make it as a very good presence, okay, just take this all this side and this side, and inside you can create a subsystem. See, if you want to create a subsystem, select the portion which you want, and I'm selecting portions except my input and output. Okay, so right click on it, create a subsystem from selection. It will be automatically created a subsystem. Just a minute, I will place it and I'll come back. Okay, this is only for just showing a good output. So I can say that this is my battery pack. If you want to create a, if you want to make it as a more comfortable again, you can add some images also. Okay, how to add image, I'll tell you. Okay, so right click on it, make sure that your images in available in the folder. Just go to website or anywhere, download some images which is relevant to your program. Okay, so then right click on this subsystem, go to mask, add icon image. Click on this add icon image, it will ask you where to browse. Okay, just click on the browse to my work. So where I saved to MATLAB programs, here I'm having one images, just adding it. Click OK. So you see, it's nothing about the image with respect to lithium ion battery. So this is the way you can develop more features on MATLAB. So this program will give you a complete battery pack calculation for a given electric vehicle specification. So what you can do is, what are all the things you can calculate? Number of cells connected in series, number of cells connected in parallel, total number of cells, total energy, available energy, total weight of the battery, total volume of the battery, and then range of vehicle according to the given specification. Okay. Now we'll go to the practice. This is my one more program for your practice. I'm going to, so whatever we did it, it's a four-wheeler specification. Now we are going to do it for two-wheeler electric bike. Okay, so what is the thing required? For a given two-wheeler, the bike is designed to have a range of 80 km. See, that's what I mentioned in my previous case. So in this simulation, we used the usable battery capacity is volt into ampere hour into depth of discharge, because I'm calculating from source to battery. Now we are going to calculate from load to battery. I want to drive a vehicle which covers 80 km per day, okay, which consumes 18 point watt hour per kilometer on average from the battery pack to operate. So I need a battery pack. That battery pack consumes 18 point watt hour per kilometer. Okay, and that battery pack should cover 80 kilometer at least. And the depth of discharge which is considered in this case is 90%. To operate the battery, I need an operating voltage of 60 volts. So here one more thing is added here, the auxiliary power. So auxiliary roads will be there. If you consider a two-wheeler, headlights, brake lights, indicators, horn, these are all actually auxiliary roads. To drive that auxiliary roads, we need a power. For that power also, for that auxiliary roads, the power required is 2.5, the energy required is 2.5 watt hour per kilometer. So what you need to do is, here the cell parameters into single cell. This is a single cell parameter. See, the combination of single cells connected in series and parallel is called battery pack. Okay, don't confuse. So before calculating, what you need to do is, what is the energy consumption for driving a vehicle is 18.5. What is the energy required for auxiliary load is 2.5. So total power you required, total energy required is, how much it comes around 18? So 21 watt hour per kilometer. So you're going to design what is your energy consumption. In our simulation, that was 88. Remember, 88 kilometers, 88 watt hour per kilometer. So 88 watt hour per kilometer is for car. But in this case, the energy required is, okay, energy consumption is 21 watt hour per kilometer. Okay, this is one case you need to calculate. Second, if you are calculating the available energy, how to calculate available energy? How to calculate the available energy is very simple. See, if you look at this, I need volt into ampere hour into depth of discharge. See, depth of discharge is given. For practice, depth of discharge is given, it is 90%. What is ampere hour? Sorry, what is voltage? Voltage is given, I need a 60 volts, which is given. Then how to calculate ampere hour? We are having a total capacity, right? What is the total capacity? Total capacity is there. So from the total capacity, you can easily calculate which one? Ampere hour. Ampere hour. So based on the given data, you can do the same thing also. Clear? Okay. So I hope you got some clear idea about how to calculate the battery pack calculation. Thank you. Kindly subscribe to the channel. If you have any doubts regarding the practice, regarding any MATLAB, please drop a mail to this mail ID. Thank you.